or will be joining this live. Here you go. You can see Baji finishing his dinner. They just got their food, their meals, and I wanted to come on here and do some catching up with you guys and make sure that we are all good and we can continue with our topic from last time in cosmology. I do hope that many of you will be joining tonight and cannot wait to see all of you and make sure that we are all on the same page here because I have been having some issues on the live and I think my last live kind of went away. So um, it would be lovely if I see people joining and try to make sure that it's working. So if you see this, please do say something in the chat and let me know. We are going to be covering some topics from this book that I just now tagged. Not sure if you can see it yet, but just tagged it. We're going to be using this book. I was cleaning up the countertop before I came over here. This is Astrophysics for Dummies. A Wiley Brand, Cynthia Phillips, and Shayna Prewer are the authors here, and we will be covering the topics from this book. So I do hope that I see many of you hopefully joining, and you can say hi to Baji and you can say hi to his mother, me. We're gonna be switching out this cat tree really soon, so this is gonna be one of the last opportunities to see this cat tree. Hi, my music. How are you doing? Hello. Hello, hello, hello. Really happy to see you all. Are you seeing the book that I just tagged? Is it showing up in the live? Thank you so much for the gold coin. I really appreciate it. Oh my gosh. Look at you guys. Thank you so much. Here is Baji. My music said, hey, Ruger RV has sent a gold coin. Thank you so much. My music is saying I'm good, not the usual physics at the table tonight. There's no book showing in the live. Okay. I will make sure that it's tagged. This is the book that I tagged, and it may not be showing yet, but I will make sure from my laptop that it gets tagged. So thank you for letting me know about that. Thank you for liking the live. Thank you for liking, sharing, subscribing, everybody. Please do give us a like, give us some heart emojis, give us some love. Really appreciate it. I wanted to show you guys Baji first so that Baji and his siblings. I think Suji has gone upstairs already, but I wanted to show you him before I sit down. That's a long hallway, ma'am. Oh, thank you. It's not that long, but I guess it's kind of long. Uh yeah. Well, Suji did have a poop in that hallway earlier today, and Mama has cleaned it now. And I did let her know that that is not the spot, but sometimes she likes to leave me a little surprise in that same hallway. But anyways, that is life as a cat mother, and we also do physics on this channel, so I really hope that you will stay for that, and that many of you will be joining continuously throughout this live. I'm good, not the usual. There's no book showing. That's a long hallway. Okay, thank you so much. Can we get 10 likes? That would be most excellent. Most excellent indeed if we could get 10 likes, my ladies and gents. I need to so here's the grocery box that I kept because, of course, they love it. I need to get some water. Jeremy is saying no. No to what, my darling? Hello, Carlos. Oh, thank you so much for all those emojis. Please do double tap the screen and give us some love, likes, share, subscribes. Thank you so much. And I don't know what happened. If you went to my other live, I don't know what happened. So by the way, guys, I changed the curtain. Um, it used to be a weather curtain for the winter, but now that it's spring, um I changed it. And I also need to change this cat tree because it's extremely worn out, but hopefully that will be soon here. Get me some water too. I'm thirsty. Oh yeah, I need some water here. Um, so hello everybody. Thank you so much for joining. Give me one moment. Let me get my water and I will sit down with you and you will see my face and everything like that. Like normal. And it's going to be a physics live. I will also get my cup. Maybe pour myself some almond milk. Never cleaned the gym today. A little while ago. Baji, you're back. Baji is back to is it worth just reupholstering it? Actually, yeah, I don't know. That's a great point. Um, it's not the most sturdy cat tree. So I always thought that it was a little weak. It always had it always had a bit of an issue with being the sturdiest cat tree. It it kind of wiggles a bit. I feel like I can hopefully find a stronger, more solid cat tree. Up, off, 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 and down. Off. So, anyways, my music and everybody. Is this an ad? Well, it's my milk, the milk that I will be drinking. So maybe it's an ad. I don't know if they are sponsoring. Hello, my lovely people. Let me see. Are all the settings set? Is my face facing? I don't know if my face is gonna face too much today because I feel like I have a few pimples on my face right now. And I went to the gym and um I'm a little tired. Hello, Hoot Owl. This home actually does not smell like cat poop because we do a good job of cleaning around here. But You know, poop is a part of life. It happens and you just gotta clean it up, you know? So, not to not to worry about that. So Stephen is saying, oh, Stephen, my member. Stephen, my member, is saying hi. Hello, Stephen. I'm gonna push this a bit farther away because I feel like my face is in your face. Hurry up and say the rankings while I have a good score. Oh my God, you're right. You're right. You're right. I need to do that. Jeremy, everybody, if you want to improve your ranking, then please do what do you call a like, share, subscribe, some emotion, some emotions and emojis. Um, Snokomoe, some gifts, some super chats. Now is the moment I will be calling out the top fans in just a minute here. Hey all, said hi. Hello, Steven. Ryder. Hello, Ryder. Jeremy is saying great advertisement. 10 likes for B. Thank you. Can we please get 20 likes for B? That's me. It's been a while. Good to see you again. It really has. Snokomoy is saying Buttercup. Hello, Snokomoy. Thank you so much for being a supportive person on the chat and in my comments. I really appreciate it. Thank you, Jeremy. Thank you, Steven. Thank you, everybody. Steven, I haven't seen you and I did miss you. Ryder, hello. Hoot Owl, hello. My Music, hello. Kintoli, hello. I may be confused, but is the cat in the grocery box? Yes. Mm-hmm. Yeah, there is a cat in the grocery box. Hello, Kintoli. Um, hello again, Jeremy, Carlos, My Music, Ruger. Thank you for the gold coins, by the way. And who are, oh my God, guess who the top fan number one is? Number one is My Music. Wow. Number two is Steven, and number three is Jeremy. Number four is Brian. Number five is Ruger. How did that happen? Ruger did a gift. Number six is she is okay. Okay. Number seven is Carlos. Number eight is Ryder. Number nine is Hoot Owl. And number 10 is Snokomoy. Snokomoy, even I feel bad that you're at the bottom. Wait, I heard a noise. What just happened? Oh, my hairband fell. Steven Sky Shenanigans. Good to see you again. Hello, whoop-de-doo. Steven Sky has been my member for 11 months. Thank you, Steven. I was reading off the top fans list, the leaderboard or top fans list, and whatnot. You are on the list, Snokomoy, but I feel like you should be higher. You're not number one yet, Jeremy. What are we counting? Hello, Kintoli. We were counting the top fans, the ranking of you guys. Snokamui, do you have kids? Hello, Kaden. I was your first member. You are my first member. Kaden Jane K is saying, do you have kids? Oh no, I dropped. You did. You did. Okay, guys. It is wonderful to see everybody. Are you ready for some physics and some cosmology discussions? My Music is number one, number two is Steven, number three is Jeremy. Okay. Yeah. I checked it again. I thought it was the stalking list. Stalking list. Well, I don't know. I don't know. I think it's just the activities of the people on the live here. You didn't answer my question. Oh, well, I have feline babies, yes, but I do not have any human babies of my own. I just consider the whole world my baby. I think I birthed the planet. Oh, my laptop is quite dead, so I guess we will not be looking at that, but I will share the live from my phone here. Do you want to have actual kids? I'm watching from the window, peekaboo. I don't know, why do you ask? Quite an intrusive question there. Um, is what do you call? Is Reese here, my mod? And also is what do you call? My other mod. Where are my mods? Are you here? I think Steven. Oh, that was you, Steven. Okay. Thank you, Steven. You're a mod. Oh, thank you so much, Steven. Thank you for being here. Okay. Okay, we are live. Thank you, everybody, for joining. There is some people here. I actually wanted to do something on my to get my live monitor going. You did. By the way, guys, can you please like and share and subscribe? Mhm. How is your book doing, Stephen? Mm. Oh no. No, 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 no. I want. I feel like I already hit the not hate button. Oh, thank you. I am not finding my live on my YouTube studio, and I'm trying to get it up so I can like share it and whatnot, but I don't see it. Hi, Barry's money. Hello, Barry. You should do a super chat. Uh, okay. You guys can still see me, hear me, all right, right? I'm working on book 6 now. Okay. I will take that as that you can still see me and hear me and all that stuff. And I think I'll just get going here. YouTube is being a little wild for me, so I'm not sure what is going on. So last time we actually talked about cosmology, and this will be kind of a continuation from there. So remember, we often discuss the beginning, the evolution, the various stages of the universe. And we have been talking about, we've also mentioned about the cosmic ingredients and the Big Bang and the Big Bang Theory, the expansion of the universe, the cosmic microwave background radiation. All of these topics we have talked about, and a number of them actually in quite a bit of detail we've talked about. Okay. So it would be lovely if you have been here before and kind of follow along with me here. But if you're also new, then no worries, because we generally give some background so that you don't feel like uh it's totally making no sense, hopefully. But also remember that the more you come to the lives and the more you kind of listen to the videos that are already posted and things like that, it'll be much more obvious what we're doing here. Okay. Um, Thank you, Barry's money. Barry's money is saying, "There you go, sweetie," and he did a super chat. Thank you so much for the super chat, Barry's money. Thank you, Barry's money. In book 5, I continue my story that there's something very cute about you. Oh, hello. Hello, BID6HX. Thank you so much. Well, I do appreciate it very much. Let me make a goal actually, because I forgot to do that. So if you are new here, remember that um, you should subscribe, because once you subscribe, hopefully you can keep coming back to these lives and the topics we discuss will become abundantly clearer. Okay, let me also heart and like Barry's Money's super chat. Thank you, Barry's Money. Thank you for the gifts too, by the way, everybody. Thank you so much. Um, and all that. So my laptop is not working, so I'm kind of hoping that the because usually I can, do the live monitor thing from there, but it just is not working. Sometimes it actually uh, makes my life go away completely. So you really never know what is going to be happening here. But I hope that we can get through the topic. Okay. I made a goal for super chats, and I also said to like and subscribe and pinned it. So please keep on keeping on. So in this channel, we have the cutest cats. We have Baji, one of the cats, and his siblings. We have me and my face. And we have discussions about physics, astronomy, astrophysics, and cosmology. Thank you so much, everybody, for being here. Really appreciate it. And thank you so much for your gifts and your super chats, which Steven Sky has done a $2 super chat. Thank you so much, Steven. Also, Steven is my first member. So I do hope that tonight will be a good discussion and that many of you are joining and also becoming part of the community here and subscribing and liking and all that. And if you want to become a member, that is one more way to support me. So but also you can do gifts, you can do super chats. Thank you so much. Thank you. So we have already started a discussion of dark energy last time. Okay. So some of this, and this is of course from this book, which I tried to tag, but I don't know if you can actually see it tagged or not. This is Astrophysics for Dummies. It's not my choice of titling, the title. I don't really like the dummies part in the title, but it is written by Cynthia Phillips and Shayna. And what's the community about? The community is about learning physics, astrophysics, cosmology, astronomy. That is what it is about, indeed. Is there any way that I can make sure? So I thought that I tagged the book that we're using. Are people not able to see it? I'm kind of done about listing. About listing. Hello, Snokamoi. Hello, Ray Appliance. I don't know what you mean by listing, but okay. Um, Wait a minute. Why is it not? Indeed, I don't know why this is not showing up. Because that is a little disappointing. Okay, so we have talked about all of those things that I just now mentioned. Origin of the universe, the evolution of the universe, most importantly, cosmic microwave background radiation, and also sort of a baby picture of the universe, which we get from the cosmic microwave background, these leftover photons from the Big Bang, and which show up as a pretty low temperature signature at this point. When we measure it, and it's isotropic and mostly homogeneous actually, um, except for of course there are little fluctuations in it that are actually a matter of huge interest in cosmology because they may hold the secrets to why we have galaxies, because of course once you take a baby picture of the universe and you look at the universe now, you see that there is quite a bit of a difference. We used to, for example, have no galaxies in the past, and now we have galaxies. So um, so very much so, the universe has changed. Just like you and me, the universe also evolves. It's not stationary. It is not, something that is stagnant. It continuously changes, and we have been expanding, for example, from the start. And we are, much bigger, much cooler, and much less of a, photons being energetic and bumping into everything and creating a mess, which used to be the case, but now it's quite different than that phase, right? And at some point, we started to clump uh, ordinary matter and make the first galaxies and stars, and then that gave way to, of course, the next generation of stars, and the next and the next, and that's how we are here, because we are um, made of stardust. We are made of things that are made in the stars, and then when the stars die and spew all their not all their, but much of their materials into the interstellar medium, then that can go on to make a gas cloud, a nebula, whatever, and then that can again condensate eventually to make something like our solar system. So that's where we're from. We would not be here without that kind of process. And the stars have made all of the elements that are heavier than hydrogen and helium, because only hydrogen and helium, tiny amounts of helium and even tinier amounts of lithium, were made in the Big Bang. And we also talked about that in a Big Bang nucleosynthesis topic. So I haven't read from the book yet. This is called Astrophysics for Dummies by Cynthia Phillips and Shayna Priver. I've been trying to tag the book and show you it, but for some reason YouTube is not showing you the book. But in theory, I tagged it, but I don't know what's happening in practice. And also my laptop is dead, so I cannot do something there either. But so far, I'm kind of summarizing. I'm not actually using the book yet, summarizing some of the things that we have talked about. Okay, so this whole situation of the Big Bang nucleosynthesis, um, coming from, giving us hydrogen, which is still the most abundant element in this universe, and also tiny amounts of helium, and you, that sort of thing also is actually a discussion in cosmology. We've talked about that, but in general, we've also mentioned how big picture in our universe we have five cosmic ingredients, and these are these are ordinary matter. That's the stuff you and I are made of. Sometimes we call it baryons in cosmology, and we kind of lump together baryons with electrons in that category, but they're actually not really in the same category. So pretty much baryons are protons, neutrons, which of course are in the nucleus of the atoms that we are all made of, but electron is also part of the atom, right? So anyway, whatever. So there's baryons in the universe, there are photons in the universe, that's light. There are neutrinos in the universe. Neutrinos are another type of particle, which is kind of like a much lighter and no charge cousin of the electron. Uh, And then there is dark matter in the universe, which we've talked about, which is a mystery. We don't really know what it is, but we try, we do research on it. And then fifth thing, or fifth ingredient of the universe, is dark energy, which is going to be something we look at tonight. So and we're continuing a discussion from my previous live um a week or so ago. So, these last two things that I mentioned, dark matter, dark energy, these are two different things, and they are both topics that are mysterious, as in we don't know exactly what's going on with them, and it is each a topic of research. Indeed, yes, dark energy is definitely something that we don't understand. Okay. Oh, by the way, Thank you so much for the super chat. Liqueur. Butte. Hello. Hello so much. What do you think about the scientists severe? Oh, I don't know. I don't know. I hope that that people are safe and healthy. But I don't know. I don't know. What do you think about the scientists? Oh my gosh. Well, Liqueur Butte, thank you for the question. All that is true material, but there is still the problem of consciousness. Oindree. Hello, space-time entanglements. Good to see you, everybody. Handle 8 is saying, do you think they were transferred to a special department? Uh, I don't know. I don't know. I don't know. I really don't know. What a beautiful brain you are. Oh, thank you, Bitman. I friend request you a while ago. Hello, John. Friend request me where? In Facebook? I don't open Facebook much. My Facebook posts are mainly the Instagram posts also getting shared in Facebook. But I do appreciate it. I'll definitely check uh and whatnot. Thank you. Barry's money is saying it's what we cannot see is what I'm scared of. I like the subject. Thank you. How is it possible the billions of neurons in our brains give rise to this thing called consciousness? Is some of scientists are cute brains and beauty. Thank you, thank you, thank you. So consciousness is definitely an interesting topic. I am talking about physics here, cosmology, astronomy, astrophysics. I don't think that consciousness is something that we really explore much in these sciences, but of course it is something that we have questions about. So that makes sense. So I wanted to say more about dark energy because it's kind of part of this um, effort to share what is going on in physics, cosmology, all of that, because I don't know how much that sort of thing is really, properly distributed to the public, especially matters and topics that are currently being researched. So I wanted to mention and clarify about dark matter and dark energy. Okay, please share and please like and subscribe and share and tell your neighbors, tell your lovers, tell your sisters, everybody about this live and to join the channel. Please, thank you. And there are many episodes already recorded under the live tab already on topics like this. You should listen to them. You should fall asleep listening to them. And I also have videos, clips, shorts, all that. So when you come across those things, please do like and uh, share and subscribe. So, so dark energy as a topic is not the newest, actually. It is being heavily researched, of course, and there are many efforts. And of course, we had to um, advance significantly to understand and start to measure the universe in a way that supports finding more about dark energy. Because you might have found already that we actually need to be looking very far away sometimes when we try to understand dark energy, because we kind of mentioned in the past lives that the farther you go away, the farther you go away. So dark energy is this mysterious thing that is accelerating the universe's expansion. Okay, and you might wonder at what scales, right? Because in our neighborhood, in our cluster, we're actually more under the power of gravitation. So gravitation is controlling us in a way that we might not really appreciate that the universe is expanding, right? Because that expansion and that acceleration of the expansion is something we notice farther away. Farther away things are getting more and more farther away like. And so closer things like, say, obviously the sun, the earth, the moon, this solar system, this galaxy, or even this cluster of galaxies, I believe, as far as I understand, are, you know, interacting with each other, and we're in a more clumped state, and we're under gravitation, which brings things closer. Gravitation, it's the only always attractive force, if you consider it a force. For example, sometimes it is, listed as one of the four fundamental forces, and it's always attractive, contrary to electromagnetism, for example, which is, you know also repulsive sometimes, when with like charges, and attractive for opposite charges. But gravitation is attractive. So we are under gravitation in the local. Okay. But when we consider this expansion of the universe and how it has gotten accelerated, that is caused by something else. And we call that thing dark energy, because we don't really fully get it. We don't fully understand what this dark energy is. And we will read more from the book about this, but that's what's going on. And of course, I was about to say that it's not a very new topic, because as old as general relativity, so over 100 years ago at this point, we have had a thing which actually caused some confusion or some embarrassment or something, called the cosmological constant, which Einstein actually introduced in order to kind of account for the fact that the universe is not collapsing upon itself under gravitation, because, of course, he worked on general relativity, which is an upgraded theory and understanding of gravitation. So when he was faced with the problem that, well, gravitation is attractive, makes things come closer, it makes matter clump, then why doesn't the universe just collapse upon itself? Why are we, why are we sort of stable? And stable is what people thought we were at that time, because over 100 years ago we didn't have um, the measurements and the observations that we have today. And especially thanks to Hubble, we started to see later on that, indeed, this universe is much bigger than we thought. There are many, 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 many more galaxies than we thought. And actually, not only is the universe stable, except it's not, because it's actually expanding. So it's not contracting, it is actually expanding. So, cosmological constant was intended to just kind of balance out gravity, to have a term that is an anti-gravity term, so that you kept things sort of static against gravity. Actually, keeping things very static is actually sort of not stable, but that's what the intention was at that time. But then, to our surprise, to Einstein's surprise, to you know maybe some amount of dismay, really, we found that actually the universe, it's not about keeping things balanced against gravity. It actually is that there is something else going on, where the universe is expanding. And not only that, the expansion is accelerating. And we got proof of that in the 1990s. So much more recently, I think it was 1998, where sort of competing groups were uh, competing groups. No, a lot of this is actually experiment and measured data that I'm talking about. The So, for example, this 1998 discussion that I'm talking about is, see, it says, when observations with Hubble Space Telescope of extremely distant supernovae showed that way back when these supernovae happened, the universe was actually expanding more slowly than it is today. So in 1998, we had an enormous data set that was analyzed by different rivaling groups, and they came to the same conclusion, and they won Nobel Prizes. And you can look this up in case I'm quoting some of it wrong. Uh, and it was based on experimentation, right? This was based on observation and measurements of the supernovae and the supernovae data. And they found that this universe, our universe that we live in, is not only expanding, but its expansion is accelerating. And how is it doing that? Basically, the farther away you go from us, the more it's going away, away, like, not coming closer, closer, like, but away, away, like. So the expansion is accelerating. Okay, but it doesn't happen close to us. Definitely does not happen in our local neighborhood, which of course in cosmology scales is kind of like our galaxy and our neighboring galaxies. But farther away, it uh it it actually happens, and it accelerates to the point where you might wonder, well, if everything is speeding up, like going away from us, that are far away things, there could be parts of the universe that we'll never know. And that's actually quite sad and a little bit scary, where information could be lost and probably is lost because things farther away are just getting farther away more fast like. And so the acceleration of that expansion is probably taking away things from us forever, and we'll never know. So that is part of it. Okay, so hi Abraham, hi space time, hi Lupa, hi Hyman, hi Cloud, hi Deepak. So dark energy, oh yes, you did say, which attracts matter, dark energy acts as a repulsive, pushing galaxies apart. Yes, but only at larger scales. Do you like the Large Hadron Collider? Sure, why not? Barry's money is dark energy is a mysterious dominant force. Yes, that's right. Good job. Thank you, Barry's money. Which attracts matter. Um, so dark matter attracts matter, but dark energy is so dark matter and dark energy are two different things. Okay. Deepak is saying I don't agree with you. It's the other side. Okay. What do you mean by the other side? Lady Sheldon. Hello, Cloud. Hello, Lupa. Hello, Human. Hello, Beckman. Hello, Spacetime Entanglements. Oh, really? I was lucky enough to visit the giant radio telescope in Arecibo in Puerto Rico. Oh, very nice. Thank you for going live. Thank you, Abraham. Hi, Pranay. Why are you so beautiful? Today I look a bit out of shape, actually. I feel like I didn't do my hair. I got back from the gym. Hi, Dark Energy, YB, hello. 24-hour stream, let's go, me and B all night. Uh, is it saying that this is a 24-hour stream? But okay, okay. Hi, Bitman, hi, Jeremy, hi, YB, hi, Abraham, hi, Pranay. Hello, John. Everybody, thank you so much for being here. So, and can you please like the live and share and subscribe and all that stuff? So in 1998, they did the analysis, and we covered that in previous lives, where they actually saw, even though competing groups, different groups independently found this, they actually agreed that um, that what they were seeing is this confirmation of the acceleration of the universe's expansion. So it is based on data, it is based on measurements, and it's based on observation. Hi, Ben. Hello, shalom. Peace. How are you doing? If you like science, there is a cool podcast. Oh, very nice. Thank you, John. Ben, how are you doing? So let me read this little part because we kind of covered this already, but so why do we need dark energy? Remember those important studies from the 1920s by Edwin Hubble, ideas that ideas that solidified the theory that the universe is constantly expanding. For most of the 20th century, so that's the 1900s, astrophysicists were confident that they understood the timeline. The essential story was that the Big Bang happened and the universe started expanding. But over time, billions and billions of years, the gravitation attraction of all the matter in the universe would be enough to slow that expansion down. So this is what was going on. So expansion is consistent with the Big Bang. So the Big Bang, of course, is a theory, but it is also backed up by certain measurements and observations. And one of the uh, things, expansion is actually consistent with the Big Bang being the correct theory. But then billions and billions of years have passed since the Big Bang. So this is kind of saying that, well, at first, of course, there was not, this like matter wasn't huge. It was a very radiation dominated universe. Photons were very important. Then we started to form galaxies, and gravitation is playing a bigger role. So would this expansion kind of slow down because we're really more dominated by gravitation at this point? That is what people were thinking, but that is actually not the case. So listen to this. So this theory, and so remember also the thing with Einstein being uh faced with that question of why haven't things collapsed, because Einstein is giving us general relativity, which is a theory for gravitation, again another theory which is very successful because it predicted lots of things that have all come true actually, right? So even more, just as an example, even as recent as the last 6 or 7 years, we saw gravitational waves for the first time, directly measured from far away, cataclysmic events. And gravitational waves are also a prediction of general relativity. So, general relativity is largely considered a very successful theory that successfully predicted things that were so successfully observed and measured and experimentally verified. So, but then general relativity is what? It is a gravitation uh, explanation. Okay. So, when you, of course, spend a lot of time thinking about gravitation, you might just ask, well, in this universe, if gravity, why haven't things kind of collapsed? Right? What is something kind of acting against gravity? Or are we just not there yet? Have we just not collapsed yet, but we're on the way? Are we, is the universe getting compressed over time? Right? So to kind of make the universe stable, although that's another whole story, or let's say static, right? Because static is actually not stable, but to make the universe static, Einstein had introduced cosmological constant. This cosmological constant turns out to be basically the modern day dark energy, which is actually acting against gravitation and expanding the universe and also accelerating its expansion. But back then we didn't know about that. So then people's understanding that there could be a slowing of, hi Unspoken, hi Ben, hi John, hi Bitman, how are you? This understanding that our expansion of this universe may be slowing, even though of course it expanded, and of course that's why we got here. This was what people were thinking, but that is not the case. That is not the case, and here's why. It was observed, and experimentally we found that is not the case. Okay, so this part is not just an idea or anything. Remember that if there was no dark energy, that might actually be a more comfortable um outcome, if you will, right? Because it's never comfortable to know that there is something we don't know, or it's never comfortable to know that there is something that we don't understand. So people would not be making all this stuff up if this was not, in our faces. Okay, so listen to this. So the theory about things slowing down, as in the expansion slowing down, really changed significantly in 1998 when observations, so these are actual data being taken by Hubble Space Telescope, of course, named after Edwin Hubble, who gave us, a lot in astronomy observations in the 1900s. Huge, huge contributor. And thanks to him, we actually know about the expansion and about all these different galaxies that we didn't know existed back in the 1900s. So anyway, the observations with Hubble Space Telescope of extremely distant supernovae showed that way back when these supernovae happened, so these are very distant supernovae, these are not things that are close to us. So the most extremely distant supernovae, the observations of that showed us that the universe was actually expanding more slowly than it is today. This means that contrary to popular belief, the expansion of the universe was actually speeding up, not slowing down due to the force of gravity. So, they took a lot of supernovae data and there is a way, so we won't go into it much because we have actually talked about this data set in the past, but basically they designed this experiment, if you will. It basically is an experiment. Like it involved a lot of supernovae data, and they designed it in a way that would tell them, um, that would show them that some of the supernovae were dimmer than expected, and that was happening because of the expansion of the universe and the expansion speeding up at greater distances. So yes, Desi is one of them. Yes. So how they designed that experiment is also very interesting, but we won't get into it right now. But they used a bunch of standard candles. You can look it up, and that's how they knew about this acceleration. So how could the universe's rate of expansion be increasing over time rather than decreasing? Okay. An undetermined force must be responsible for that increased rate of expansion. This potential solution came to be known as dark energy. So that's just the name it got. And it's the best explanation we currently have as to why the universe's expansion is accelerating, not the galaxy. I think that's a typo here. Are dark matter and dark energy the same? No, they're not the same. They're quite different. Dark matter is the name for that invisible substance responsible for keeping galaxies together, whereas dark energy is the force that pushes the universe apart. So, dark matter is another whole situation. Okay, this is some extra matter that does not interact with light, but does interact gravitationally and actually is found even in our own galaxy and also in other galaxies, and probably played a role in the formation of the galaxies just period in general. So when I mentioned earlier about um, the universe not having galaxies at first and then eventually making the first galaxies and stars, um, it's been a while. Yes, hello, how are you doing? What I did not mention, because that too is a topic of research at this point, is that sort of that large scale structure, which is the distribution of matter in this universe and how that distribution is the way it is, etc., etc. That probably has a role of dark matter in it. And understanding more about that would actually be really terrific, right? But dark matter is another mysterious topic. So it's different. So dark matter interacts gravitationally. It is matter that is helping with clumping and bringing things closer and stuff like that in the universe. So it is not the same as dark energy. Dark energy is another whole thing which causes the expansion of the universe to accelerate. So it could be some kind of force, it could be something to do with the vacuum. Sometimes people call it vacuum energy. It could be something that's going on that we don't really understand yet, but like maybe some quantum mechanics and something that makes the universe ultimately expand and accelerate. Okay. So so we will keep going to understand about the origins of dark energy, because we kind of went through the transition period and when we think the universe kind of changed into this phase that it's in right now, etc. Hi Thomas. We actually went through that already, and so now we will actually get into origins of dark energy, sort of the story, and some of this I covered. I told you about the cosmological constant, but we will get into that. So there are some basically this is people thinking what it could be because we don't know yet what it could be, and so we'll read about that. Um, all right, so it looks like there are like five different takes here with understanding what this dark energy business is, and we will quickly cover them. So before that, let me say hi to people. Hi Thomas. Snokamui, Baji is right here beside me on the couch. Hi Paxton. Hi Ben. Hi Sheffer. Because dark energy pushes. Thank you, Ben. Galaxies, stars, and even atoms are eventually torn apart. Because dark energy pushes matter apart, it acts as a brake on the growth of. Yes. Oh, very nice. Unspoken, how are you doing? Did you like and subscribe and share? God loves you. Have a great day. Thank you. Hi, Nikita. How are you? Hi, Thomas. Thomas is saying, I'm Ashkenazi Jewish. My sister, I would like to invite you to my synagogue. Oh, very nice. Where is your synagogue? Synagogue. Because dark matter acts as the gravitational scaffolding that clumps galaxies together. Where's Baji? Baji's here. Did you speak Yiddish? Ciao, ciao. El Challen, how are you doing? El Challen, I've missed you. I haven't seen you in forever. What if dark matter is just a void that needs to be filled with matter so it attracts it till it's. So it's not a void because dark matter is already interacting gravitationally. Hi, John. What about space attracts you? Oh, attracts me to it. Doing good, about to go on summer break, learning piano. Oh, very nice, unspoken. 8, death from below. Hello, 8. How are you doing? I'm gonna read off the top fans again in a moment. Let me take a few sips of my milk here. Yes, I hope so. I hope uh that we find out what dark matter and dark energy are. Mm-hmm. Do you mean dark energy, Ben? So no space. Yes, absolutely. So, what we're about to cover is going to be certain ideas and sort of the origin story for dark energy. And some of this will be kind of a review of what we were just talking about, especially the cosmological constant. But I did want to mention the cosmological constant because, of course, that is truly kind of the origin story for dark energy. And it dates back to when Einstein worked on the general theory of relativity, which, of course, is you know, quite a. I did see your kittens. Thank you. You should post an update on them, an update picture. I went to my, you're right. I went to my, um I am able to see you guys' posts. I went to my, here, I'll show you. Um Community. When I go to my community tab, oh my God, there are more kittens. Oh, I just saw this. Ben's kittens. Two boys and two girls. Oh, I see them. I see them. MJ Olnir is saying shadow is anti-vision. Glad to see you smiling in real time. Cold energy. Dark matter is a cosmic web. Unfortunately, humans. Oh, why do you say that, MJ? Do I think dark matter is a field or particle? I don't know. I also, so let me see. Ben, I see your kittens. Thank you so much for posting your kittens. They are wonderful. 1, 2, 3, 4. I see them. Little babies. I see them. They're little babies. They're babies. They're so cute. Please do take care, good care of them. Baji's coming to say hi to your kittens. Hi, Baji. Hi, Baji. Say hi. Say hi. Baji, are you here to study the cosmological constant? I think you should. I think you should introduce it. Origins of dark energy. Einstein included a term to balance out. Baji, here. Baji. Baji, don't go. Baji, what do you think dark matter is? A field or a particle? Please do like and subscribe. Tiger like Winnie Pooh. Alondra to some girl. His food. It's lovely to see the kittens, Ben. Benito had said hi to me. Dialectical also shared 2 cats. Thank you, Dialectical. I'm happy to see your kittens. Hi, Kikshi, Heather. Hello. Hello, Stock. Hello, MJ. Hydrogen and anti-hydrogen quantum world. You forgot his gray? Okay, so let's keep on going. Einstein included, so this is going to be the first kind of origin story for dark energy, and it's very important. So Einstein included a term to balance out the universe and make it static. So this is what I was talking about earlier. It's the same thing we're going to review. This term is called the cosmological constant. The constant lets us describe how dark energy affects the universe, but does not tell us what causes it, sadly. Although that term was quickly discarded after Hubble's evidence of an expanding universe became known, the idea of this constant has recently been coming back as an energy density of empty space. So we kind of did rejuvenate, or this cosmological constant has sort of reincarnated as a more modern meaning. Um, and really this concept of an anti-gravity term being as old as general relativity and cosmological constant, that is still really interesting. So it was discarded after Hubble found that the universe is actually expanding, and Einstein felt very embarrassed at that time. But actually, it's kind of nice to have this concept. So the idea of this constant has recently been coming back as an energy density of empty space. Even empty space has its own intrinsic properties and perhaps is not so empty after all. One of the all time great thought experiments is the vacuum. Okay, defined in physics as empty space or space without matter, anything existing in a vacuum would make that vacuum cease to exist because it would no longer be a vacuum. Space is close to being a vacuum because it is, by definition, matter free and nearly pressure free. It is not, however, a perfect vacuum because even in its uncluttered areas, bits of gas and dust can be found drifting, and maybe something else is in there too. So it's sort of this part is about vacuum and kind of questioning what is the vacuum and is it so empty after all? How could a vacuum relate to dark energy? Thank you guys for your comments. It's very interesting to read them. How could a vacuum relate to dark energy? In developing the theory of general relativity, Einstein posited that so this is that Einstein story, that one possible source of a universal repulsive force was space itself. Just as space is not quite a vacuum, empty space is also not quite empty. And Einstein realized that space is able to make way for more space to be created. Looking at this with modern eyes, so it's sort of so basically the space creating more space needs a sort of a modern explanation. And so that's why we do still consider it, and do still kind of go from the cosmological constant to uh let's say hopefully a more comprehensive explanation. So looking at this with modern eyes, we can propose that a form of energy such as dark energy would make this scenario possible. It's possible that dark energy takes the form of the cosmological constant and is a term representing an energy that seeps out of the vacuum of space itself. This concept is sometimes known as vacuum energy density, meaning that even in a vacuum, space itself has some intrinsic properties, including its own energy. So, this is a thought, okay? So, this could be the origin of dark energy. We don't know. We have to understand it better. But space itself being not so empty and maybe having some energy of itself, which can create more space, is sort of one of the thoughts. Thank you, BID. Thank you so much for the interesting discussion going on in the chat. Thank you, Snowcomore. Thank you, Snowcamoy. Thank you, Ryans. Are you interested in teaching the subject or would you rather explore slash just learn? Both. I'm interested in all of the things. I don't know. It says Stanley on it. Hmm. What was the question, unspoken, that you're asking? There he is, behind me. There is Baji. Hmm. He is live. Okay, next theory. Okay, are you ready? We talked about the cosmological constant, which of course is sort of the origin story of dark energy, the whole anti-gravity term being introduced by Einstein. So it deserves a mention for sure, if not an entire makeover, which people do work on in cosmology. Okay, so next is quantum theory. Still not convinced about dark energy. We could maybe think about quantum mechanics now. So, are you wearing a purple pajama? It's my purple house coat. Yes, kind of like a pajama. But yes, indeed, it is a purple coat gown situation. Quantum mechanics would like to have a turn at trying to explain dark energy. So, Baji might come back forward, but that's up to him. I don't really make him do anything, he does his own thing. Hi, Baji Baba. Hi, Baji. Hi, Baji. The quantum theory of matter posits that all matter essentially has a split personality. It has both wave and particle properties. So now we knew that already from quantum mechanics. Standard physics covers the nature of particles thanks to Newton's laws, and the nature of waves is explained by quantum physics. The idea behind this theory is that the wave and particle sides of matter create interim particles that appear and then disappear. Under this quantum theory of matter, empty space is filled with temporary particles. So we're getting into something called virtual particles, which we have also mentioned before. According to quantum mechanics, these things form and disappear constantly as virtual particles. The existence of these particles could explain how empty space may acquire energy as a consequence of their brief existence. So the fact that we were talking about how empty space itself may have some kind of energy, some force, something going on in it, may not be so empty after all. Well, that would actually be quite supported by quantum mechanics, because in quantum mechanics we do believe in and think about virtual particles, which are particles going in and out of existence, completely supported by quantum mechanics. Unfortunately, there is at least one problem with this theory. Based on this theoretical explanation, astrophysicists have been able to calculate how much energy empty space should contain based on the volume of space in a particular galaxy and its expected luminous mass based on its brightness. So, putting kind of this notion to the test, the result was concerning because, per the calculations, this theory would give empty space far too much energy, 10 to the 120 times more than can be explained by the observations of supernovae redshifts. Although an order of magnitude or two in difference is to be expected with theoretical calculations of this nature, such a huge discrepancy is emblematic of a problem with the theory. So, if this was the explanation, the virtual particles going in and out of existence, which would actually be quite believable in terms of quantum mechanics, uncertainty principle, those things are expected. But unfortunately, this train of thought kind of leads to a huge discrepancy in the amount of expansion and acceleration we see, and the one that would happen if that was the case. Okay. So, kind of sad that this doesn't really account for dark energy. Quantum field theory is still working on trying to resolve this huge mismatch. Perhaps a balance is lurking such that individual terms are huge, but their sum is closer to zero. So maybe it could be salvaged. Maybe there is an explanation for this huge discrepancy. I mean, remember, like there are sometimes intermediately, there are problems with things, and then people realize something and they have to update their work. This has happened before. If you remember, or was there for the superstring theory discussions we've had. Superstring theory has gone through a number of updates and evolution based on a lot of really concerning discrepancies and things. So it's not entirely shocking if there is a discrepancy, but maybe it can be resolved. Okay, so we will see. So maybe the actual value of zero point energy is randomly generated through quantum fluctuations, and we can only detect it in locations like our universe, where its value allows the existence of normal matter. So we don't really know, but this is another idea. Number three, quintessence. If space producing itself through dark energy doesn't quite convince you, another theory as to where dark energy comes from lies in the idea of quintessence. This as yet hypothetical construct creates a form of dark energy with a repellent, also called repulsive, though repellent sounds a little bit more friendly, gravitational force that serves to increase the universe's rate of expansion. Not that we know of, so I will just say I don't know of any repulsive gravitational force, and so I don't know. This is just a thought. In this theory, space is filled with an undetectable energy field that acts like a dynamical fluid that produces pressure. Now, this is kind of sounding quite similar to like negative energy of the vacuum, etc. But oh well. This material was called quintessence. So quintessence, like it's basically giving a name or a sort of some tangibility to there being some dynamic thing in space. So quintessence, after the fifth element, defined in ancient Greek philosophy. So ancient Greeks had a quintessence. To the ancient Greeks, the four major elements. Oh, how interesting. The four major elements were fire, earth, air, and water. Aristotle added the idea of ether as a fifth element to represent what stars were made of, and it was also called quintessence, which comes from the root quint for five. Of course, Aristotle would perhaps have been surprised to find out that the stars are actually made up of earthly materials like hydrogen and iron, but his idea of a fifth celestial element was reborn in this new kind of a property that fills empty space. So I really don't know if this quintessence idea is real or not. But it has a connection with Aristotle and the ancient Greeks. The theory is that quintessence would fill space, but would also cause the expansion of the universe to accelerate behavior fundamentally opposite from normal energy or matter. Despite the spiffy name, we still have no idea what this material really is, how it interacts with regular matter, or how to detect it, or even if it truly is a valid explanation for the existence of dark energy. So this is quintessence. Honestly, the only thing I heard before reading this about quintessence is that quintessence is five, right? So because there are five cosmic ingredients and dark energy, mysterious one is sort of like the fifth one, people have thought about, like, I thought that was the reason actually for calling, like, it's another name of dark energy, quintessence, the fifth element. But as far as something filling space and all of that, I feel like um we would need a lot better explanation that just some mysterious fluid that fills space when we consider and understanding dark energy. So, you know, it's a another thought, but I would say not a very strong thought. This quintessence thing, okay? Um Fourth thing to consider. Are you having fun? Hi, Zanivy. Hello, Dr. Jagdish. Hello, everybody. Thank you for being here. To be paid. Thank you, Ali. So the next thing is tachyons. So Ben, I think, mentioned tachyons at some point in a previous live. Well, the fourth idea for dark energy is going to be tachyons. So it's kind of similar to what we mentioned about space not being so empty after all. Okay, so let's see. Space may not be so empty after all, but rather occupied by a field made of tachyons. These are hypothetical particles, so we have to learn a lot more about these before we can be sure. But these are hypothetical particles that can actually travel faster than the speed of light. Now, very hypothetical because we don't know of anything that travels faster than the speed of light in vacuum, okay? But tachyons maybe could, hypothetically, meaning they could even travel back in time. Oops. Don't run out to the tachyon just yet, though. This theory is almost impossible to prove, and here's why. I was gonna say, I was gonna say, I was gonna say. Tachyons are a consequence of Einstein's theory of special relativity, which, as you know, brought together space and time. American physicist Gerald Feinberg came up with the term tachyon in the 1960s to describe a particle with imaginary mass that arises from a quantum field. So, in quantum mechanics, you can do these things. Normal particles, ones that travel slower than the speed of light, increase their speed as energy is added to them. Tachyons increase their speed as energy is taken away. The lowest energy state of these particles is moving at the speed of light. Wow. To an observer in our fixed normal mass reference frame, these particles would appear to be moving backwards in time. Now, particles moving backwards in time is actually not, so strange in particle physics. But tachyons are a little strange because tachyons, this whole faster than speed of light business is definitely not something that we consider regular. Although the existence of these particles is controversial as at best, it's very controversial. One theory suggests that pairs of virtual tachyon and anti-tachyon particles could be fluctuating in what's called the quantum vacuum. Well, the quantum vacuum probably does have pairs of particles doing something. Uh, the whole particle antiparticle going in and out, all that stuff would be because things are kind of annihilating and existing and then not existing, all that stuff, right? But as far as are they tachyons or not, that is definitely something that we would need a lot more proof for. Results from this model. So, but here it's basically saying that the virtual particles are tachyon anti-tachyon. Okay. Results from this model seems to be consistent with current data on dark energy as well as the period of inflation that took place just after the Big Bang, where the universe was expanding, right? And the results might also be promising for dark matter. Oh gosh. However, this idea is still very much a preliminary theory. So this is a preliminary theory. I don't know if tachyons are real or not. And as far as space being not so empty, there is something going on in space, quantum mechanics like, is not, it is probably pretty likely that that is the case. Okay. So I'm not too shocked by that. Okay. Last, this is the number 5 sort of idea for dark energy while we are still kind of befuddled by dark energy and we are not sure what it is. Okay. Questioning Einstein and gravity. That is the last. And I'm glad it is the last on the list because, as I was saying earlier, if you want to question Einstein and gravity, and so question general relativity, you better have a very good case because Einstein's general relativity has had immense success. It has made many, many predictions that have all come true. Some of them coming true over 100 years after the theory came out. So you would definitely want to have very good reason to, take it and throw it out, right? So that's what this is saying. So one of the most recent thoughts on dark energy takes a hard look at Einstein's original theories for gravity and space-time continuum. What if Einstein's theory of gravity isn't quite right? What if the treatment of gravity in general relativity needs an extra term, a field that causes the expansion of the universe to accelerate? Now, I would I would think that if there was a term that we needed uh, that causes the expansion of the universe, we would want an explanation of that term. We would not just want to add it, right? So, the current theory of gravity works well in addressing the observable universe. It governs the behavior of stars, planets, and galaxies. Any change to the theory of gravity, such as a modification or an extra term, would also need to support these relatively smaller objects. However, because dark energy might be visible mostly at the very largest scales, it's possible that observing galaxy clusters could lead to evidence of this different gravity behavior. So, this is basically questioning gravity at a larger scale. Like, do we need to treat it differently when we go to larger scales, which would basically imply updating general theory of relativity? So, you know, that's another thought, but probably not my favorite thought, to be honest. But at the same time, I will say that general theory of relativity is a classical theory, as in it does not explain or incorporate quantum mechanics. Um, and it gives us an explanation, a very beautiful, elegant explanation for gravitation. But the fact is that it does not really play well with quantum mechanics. So I would not be shocked if there were quantum mechanics effects that need to be um, accounted for in order for us to get the full reality, which, for example, for dark energy. So I feel like the end solution might be sort of a combination of all of these, um, where um hi Ali, hello. Thank you so much. It might be a combination where it ends up being the case. Well, I don't know. This is just speculation based on what we've just said. It could be that it ends up being the case where we need that last bit of work to connect gravitation with quantum mechanics and understanding like about the about this expansion in terms of like we basically need that quantum mechanics explanation, just the classical theory as a non-quantum way of seeing gravitation may not be the full picture. And again, that is not shocking because people have been thinking that for a while. That's the whole reason superstring theory started being coming into existence, and unfortunately superstring theory expl- cannot be tested out. um so we don't know what's going to happen with that. But that is for you the dark energy origin story, and sort of the five different ways of looking at it. But I would say a lot of them really have to do with probably this business about empty space or vacuum not being so empty after all. And we already kind of know that it's not, because quantum mechanics allows particles and antiparticles to go in and out of existence, to annihilate, to we for us to have virtual particles, and all of that. So it would not be surprising if that was the case and there was something going on that is expanding us and making that expansion speed up at larger distances. For sure. Thank you, Snokamui. Well put as always. Whatever answers come out of quantum computers or AI must be carefully analyzed by us humans. Totally. I mean, absolutely. Hi, Darth Vader. Hi, Snokamui, Spacetime, Ali. Hope you guys enjoyed this lecture on dark energy. Um, any questions, let me know. I'm just gonna wrap it up. Next time we will talk about standard of cosmology. So I think somebody was mentioning about maybe somebody was mentioning cold energy or something I saw. Um, Hi Adler, you should subscribe and you should rewind when this gets posted and see the whole live. I think somebody had mentioned about maybe cold dark matter or something, and we're gonna cover that next. Okay, so next time, please do make sure that you join us for this. Um, Next time we will talk about cold dark matter, and um, if you missed this one, high construction of soul. You always miss the lives. Well, I hope that you get notified. Maybe you have to press the bell icon or something. Make sure you're subscribed and come to the lives, um, and catch us live for these topics. Next time we will talk about cold dark matter. I always miss the part two. Yes, well, this was sort of the part two for the last live. But next time maybe that will be like part three. Ali says, love your streams. Thank you. Oh, thank you so much. I really appreciate it. Please do like and share and subscribe. So next time we will talk about the lambda cold matter, cold dark matter model. It's a model, uh, baryonic matter, photons, electrons, cold dark matter, dark energy. So this lambda CDM model is sort of a no refunds. What happens when the sun explodes? Um, this is, I'm looking at this chapter that is going to cover the end of everything, end of the universe, or the end of our sun and whatnot. So it's going to be a sad day when we talk about that. But actually, we have talked about the anthropic principle in the past from Stephen Hawking's book, I believe. So, you know. Oh, I'm gonna get a book on Vera Rubin really soon. Vera Rubin is very important, so we must talk about her, okay? I have a blurb on her right here, though. Let's end it, well, end the reading with Vera Rubin, because this whole end of the galaxy bit was very sad for me to look at. Um, so next time we will, so let me mark this. Next time we'll talk about the lambda cold dark matter model. It's a model. Cosmology has models. I'm not saying everything is an experimentation or measurement, but much of it, a lot of it is, but I will let you know when it's a theory or a model, okay? Um, but for example, gravitational waves are not a theory. They were measured. So I will also let you know when something has been measured and not a theory anymore. Um, because we will also start to learn about Vera Rubin and her work, I think it's good that this author, this is the book we're using, Astrophysics for Dummies by Cynthia Phillips and Shayna Prewer. Prior. They actually tell us a little bit about Vera Rubin. So let's see. 10 scientists who paved the way for astrophysics. Included in that list is Vera Rubin. Thank you for sending a floating heart. Hi, Mass Mayhem. Thank you, Adler. I'm looking forward to your next session. Thank you. I always enjoy every topic you bring to the live. If I miss it, I rewatch it later. Oh, thank you so much. Yes, please rewatch. And please see the, episodes when they get posted on my live, under the live tab of the channel. As often as I can, really, at least a few times a month. At this point, it used to be a lot more regular, especially in fall and winter. The lives are a lot more regular. Right now, it's sort of a few times a month, but try to make it to all of them. And If you miss one, you can always go back and watch it later because it's posted. How do you do this? Study on this. What are you talking about? How often are you on here? Thank you, Ali, for the floating heart. I always enjoy every topic. Oh, so how many other fundamental forces of nature that we cannot there's only four fundamental forces of nature, and we can see all of them. Uh, my name is Oindree, Oindree. My name, Oindree. See, it's in my username, Oindree. The first part, Oindree is my name. So, um, there's only four fundamental forces. Shall we name them? Gravitation, number one, not quite considered a force in general theory of relativity, but in particle physics, we name it, of course. Number two, electromagnetism, the force between charges, like or opposite. Number three, strong nuclear force, the force responsible for keeping quarks together. And that is how we get protons and neutrons in the nuclei of everything we know and love, such as ourselves, what we're made of, strong nuclear force acting at very short length scales, such as of the nucleus. And fourth, weak nuclear force, which is something that neutrinos, those introverted particles that we mentioned, interact through, something responsible for radioactive decay and such. As far as things that we've discussed, like dark energy and dark matter, we have evidence for those things as well. We just don't fully understand them. So they're not, we didn't just make it up because it's a hobby. We have plenty of problems in physics uh, to work on. So it's not that we wanted to make it up, but dark energy and dark matter are things that are also coming from observation, but we just don't understand them fully. Can you shout out Marlin and Matt from Canada? Hello, Mass Mayhem is saying anti-gravity. Some chill guy is saying, can you shout out Marlin and Matt from Canada? Hello, Marlin, and hello, Matt from Canada. Um, Namrofni is saying, are you into astrology? This channel, we're mostly into astronomy, astrophysics, physics, cosmology, but I do know my sun, moon, and rising. They are Libra, and Cancer rising. What's the closest accurate mathematical formula? And that is based on, I think, like modern astrology. I was listening to somebody and the other day. Apparently, astrology used to be based on astronomy, like the actual positions of stars and planets, but now apparently that has changed, and so it may not be as accurate or something according to this particular person that was talking about it. So as far as I know, according to whatever, I'm a Libra sun, Libra moon, and Cancer rising. Do I think astrology? No, no. I would say astrology is a study, and like it- whatever, it's a study, and a study is a study. It doesn't have to, like, people work on it, people find meanings out of it. It's part of spirituality for many, so why not? And what I was trying to say is that I think there are different ways of doing it, and those things may not agree all the time. How astrology is done. I would probably be more a fan of the astrology that is based on true astronomy and like actual positions of things. But basically, I think as far as I understand, it was in history, it was the way of looking at the sky, basically doing astronomy and trying to find a meaning out of that. And honestly, I don't see Sure, find a meaning out of that. I like things that have to do with the night sky. Oindree is the Oindree is the fifth force in the universe. Thank you. Thank you. Thank you. Thank you. Ali is saying Aries. Are you an Aries? Whether it's the fifth force in the universe, I care about the position of things too. So it's not just position, right? It's also um symbolism, right? I think where astronomy and astrology might be very different is astronomy we care about like actual positions. We actually care about where things are and things like that. And astrology, I think it used to be the same. Like people actually did the astronomy and then found some meaning out of it. But astrology has a symbolic nature to it. Like it's also what the sky is saying based on, something that we're seeing and getting a symbolism out of that. So it's different in that sense. The dark force of dark fate. Well, thank you so much guys for being here tonight. I really appreciate it. I'm sorry there haven't been as many live streams as usual. Um, I'm definitely going to be trying to be as regular as possible. I have had a number of newer projects that have kind of overwhelmed me, and I did not find sort of my usual steady state cadence with everything yet. Um, but it's always lovely to chat with you guys and to catch up and talk about physics and cosmology and astronomy with you all. I hope that you keep coming back to my lives. Um, it's been a little quiet, um, but I hope many of you continue to come. Good seeing you. Thank you. You will see me soon. At least a few more times, really soon. Very serious subject. What is? Um, and if you see my videos, my clips, my shorts, please do show some love to them. Your support and love for the content really keeps the channel going. So if you enjoy all this, please do like and subscribe and share. And I hope I see you in the next live. And here's that book. And we can still chit chat for a few more minutes if people are chatting. And I hope you can see, I hope you can see where you would go. Uh, I hope you can see where you would go to subscribe or hit the notification icon, the bell icon, so that you get notified when I do go live, okay? Yes, please don't forget to hype the videos. Thank you. Burger King. Okay. Hello, Greasy Ronnie. Hello, Space Time, Cosmology, Physics, and Mathematics. Thank you. Thank you, Ali. Ali said shout out to you. Thank you. Double tap. Thank you. I really appreciate everybody, guys. Are you Canadian? I'm not. I'm in the US. Oh, somebody asked where I was. I'm in Boston, in the US. My TikTok is called Boston Girl, and I've been covering a lot of Boston content on there. Top fans right now are number 1 is Barry's Money. Hello, Barry. How are you doing? Number 2 is Steven. Hello, Steven. Number 3 is Snokamoi. Wow, Snokamoi, you've really come up. Number 4 is Ben. Thank you, Ben, for moderating and adding all your valuable comments. Number 5 is Liqueur Butte. Number 6 is Unspoken. Number 7 is John. Number 8 is Ali. Number 9 is Mind Music. Number 10 is Kaden. You know what? I have not seen my other mod, Reese, in a very long time. I'm gonna message him right now. Where is he? Boston stand up, yes. Where is Reese? Can we get 40 likes? I will send him messages in all caps. I am live. Where are you? I also messaged Charlie. Hmm. Baji baby. Number 11 is Baji. Aww. I'm a big fan. What can I say? Aw, thank you, Snokamui. Thank you, Ben. I really appreciate you all. I got an interesting message. Just reading that. So, have people liked and shared? Hi, Case. Felt none. What do you mean, Nicholas? Glad you've been feeling better. Thank you. Hi, Case. Hi, Unspoken. I am wondering where Reese is. I see your. Are you the girl that likes rockets? I guess I do like rockets, actually. Yeah. I am. I'm Cosmic Girl. Thank you for joining. Please like and subscribe. Hyper Slob. And you should rewind because we're about to finish the live and we started a while ago. I see your messages, Charlie. Yes, you're gorgeous. Well, thanks. Thank you. Thank you. Please do tell your all your friends and students about the live. Hello, Tony. Tony DiCaprio. Tony DiCaprio. Leonardo DiCaprio. Tony DiCaprio. Thank you, Tony. Knowledge is saying hello from Montreal. Hello to Montreal, where everybody speaks French. Sometimes my name becomes a French name. Ali is saying I'm a software developer. Yay! Software developers are in the live right now. Wow. Love it. I do, but they're cramming for tests right now. Salma Hayek, your mother. She is, actually. I do believe that Salma Hayek could be my mother. Hi, Salma. Ma is in her name. She is, in fact, all of our Ma's. Oindree Hayek. Oindree Hayek. Where Salma Hayek is my mom. Hi, Salma. Hi, mommy. Hi. Please like and subscribe, Salma Hayek. Show some support to your daughter. She does look like her. Show some support, Salma. I better park my car? What do you mean? I don't have a car. Knowledge kept. What's your nationality? You tell me. Hmm. Human. Can we get 50 likes? What is this I see about me getting only 39 likes? I love that. Namrofni is saying, why can't you trust an atom? It's because they make up everything. Thank you, Ninja. Thank you, Unspoken. I don't get it. What do you mean park my car? I don't get it. No, but I want you to guess, Knowledge. Oh, slow my roll. Have I talked about plasma? I have not. I don't know that. I don't think I know a lot about plasma. You tell me, John SZZ. Slow my roll. I see. Hollywood run too slow. Hollywood run too slow right now. Hello. Hi, Derby. Hi, Unspoken. Knowledge kept. You should guess. I'm not bothered, but people like to guess it on the channel. You should guess. They're saying I'm from the Hayek family. Hi, GJ. Hmm. Hi, Ali. Derby! Thank you, Derby, for the star. Oh, thank you. Thank you so much. Jean is saying, give Salma my regards when you see her again. Muchas gracias. I will. The fourth states of plasma. I will. I will. I will. Oh my God. I'm really puzzled. I'm guessing from India, possibly. Yay! Thank you for the twinkle, twinkle, little stars. She's Peruvian. I'm Peruvian. Uh-huh. I am. Megaforce, it's time for you to do a super chat. Hello to Mexico. I actually will be right back. I need to go charge my laptop a little bit and then I will come back because I want to change. You guys always help me title the lives, so I'm going to do that from my laptop. Like and subscribe, guys. One more subscriber. She's Mexican American tacos. Oh, Scott asked me in a comment if I got the plumbing issue fixed, and my answer is no. I'm somehow managing without fixing that plumbing issue, Scott, and I need more support from you before I fix it. Where are you, Scott? Aw. What a nice gesture, John Paul to airport. Thank you, Ponte Delgada. Oh. We need free plumber. We need free plumber or we need a super chat that will cover the plumbing issue. Um, so I figured out one of my plumbing issues. The other one, I'm just kind of managing. It needs it needs a plumber because I need to like replace the faucet upstairs. I just don't use that bathroom sink right now. So I'm managing without it. And I do plan to fix it. Hello, how are you this evening? Where are you in this wide world of ours? Hello, Wild Bill. I'm in the US. How are you and where are you? The plumbing is on my list. When you going live again? Scott had asked me a week ago. Well, Scott, I am here now and I don't see you. I don't. Can 10 more people subscribe to me, please? Then I get to a nice number. Unspoken, Ben, Wild Bill, Snokomoy, can you find me 10 more subscribers? Right now, the number one top fan is still Barry. Number two is still Steven. Number three is Unspoken. Thank you. Number four is Snokomoy. Number five is Ben. Ben, you have slipped. Number six is Liqueur Butte. Number seven is John. Number eight is also another John. Number nine is Ali. Thank you, Ali. Yali. That song, I like that song. Number 10 is My Music. Yali. यार पे कुर्बान है सभी. Thank you, Ali. Already subbed. I'm fixing a lot of things by myself on my house. Yeah. Problems, I'm already in Haifa is very near. Oh, you should sing more often. I am. Should I sing something for you guys before I go? Thank you, Ben. You made my day by liking my songs. Thank you. You were so kind. You're so kind. I need 10 more subscribers to reach a nice number, guys. I'll be right back. Let me go charge the laptop. I'll be right back. Okay, what song should I sing? Soft kitty, warm kitty, little ball of fur. Happy kitty, sleepy kitty, purr, purr, purr. That one? I actually don't know the song because I haven't seen a lot of Big Bang Theory. Yes, 10 more subscribers, guys. 10 more. Get your mothers, sisters, aunts, uncles, neighbors, lovers, affairs, everybody to subscribe, please. I need it. I need 10 more. I need to reach 10 more for a nicer number than what I have right now. I am doing physics ASMR. Yes, that's correct. I am. I am. Where are you from? Dhruv is asking. Well, when I sing this song, I think you will know on your own. Where I'm from is a highly hot topic, debatable. It's highly debated topic. So I'm not going to give it away. Ooh. You're not just numbers. I know your names, Nokamoi. Outfit check. Well, Here's my outfit. It's this purple house coat. Then say it. That would be really boring. I'm not saying it. You should say it. Where are you from? Just grabbing random people's phones and opening their YouTube app to subscribe. You should do that. Unspoken. I'm upset that you haven't done it already. This is quite crazy. Are you Sri Lankan? Hello, D Silva. Affairs to welcome. Where Rohan, calm down. My homelanders are here. I'm not afraid to say it. In fact, you will know it. Are you ready for my singing, guys? Make some noise. I'm very shy. I'm very shy about singing. You better hype me up. You could guess, but you don't want to bring negativity. Are you serious? कहना ही क्या? Okay. You know what? Guys, don't look at me. Don't look at me. Just don't look at me. I'm gonna put the Stanley here. Don't look at me. Don't look at me. I'm just gonna sing over here. Are you there? Sometimes I giggle. Don't leave. Okay. Where are the lyrics? कहना ही क्या ये नैन एक अनजान से जो मिले चलने लगे मोहब्बत के जैसे ये सिलसिले अरमान ने ऐसे दिल में खिले जिनको कभी मैं ना जानूं. Wait, this is quite difficult. वो हमसे हम उनसे कभी ना मिले कैसे मिले दिल ना जानूं अब क्या करे क्या नाम ले कैसे उन्हें मैं पुकारूं. Shut up, everybody, and let me sing. Just don't even look at me. Don't look at me. कहना ही क्या ये नैन एक अनजान से जो मिले चलने लगे मोहब्बत के जैसे ये सिलसिले अरमान ये ऐसे दिल में खिले जिनको कभी मैं ना जानूं अब क्या करे क्या नाम ले कैसे उन्हें मैं पुकारूं. Have you seen this song or have you heard this song before? You're adorable when you're silly. Well, I'm not adorable, I'm singing. I love this song. The next part is actually a bit hard. पहली ही नजर में कुछ हम कुछ तुम हो जाते हैं यूं गम नैनों से बरसे रिमझिम हम पे प्यार का सावन. Okay, I think that's how it goes. Stream Master, hello. This is called Kehna Hi Kya. Kehna space ki K or no he hi space kya. Kehna Hi Kya. I will share the song name with you because if you don't know this song, well, you should know this song. It's a very famous song in India. So um you need subtitles. Okay. All right. You guys are useless. You don't know the song? Here I am worried about singing this song and not being good enough, and you don't even know the song. Are you telling me that I am introducing this song to you guys? Well, you are really good for nothing. Indian, specifically Northern Indian. I am Indian, but not from the north. I'm from the east. You are not cultured enough, my chat. Let me tell you this song now. Now it is upon me. Now it is upon me. I have to tell you the lyrics. Okay. It goes as gum sum gum sum gum sum gup gup. Don't dumb it down. Fine. Kehna hi kya means fine. I won't dumb it down. Actually, it just doesn't translate very well, guys. Um, let me see if I can find the translation. Are you Indian, Bengali, American? Yes. Hello, knee crappers. How are you doing? It's not easy. I'm all of those things. How did you know? Knee crappers is saying knee crappers? Crap? Okay. Indian, yes. Bengali, yes. American, yes. How nice of you. अब क्या करे? Ooh, gumsum gupsum gupchup gumsum gupchup. This is the first part of the song. This means, would you ask someone's ethnicity in person? Actually, I get asked all the time by Uber drivers, Lyft drivers, airport, everywhere. Silent and secretive, silent and secretive. We're going to be silent and secretive. That's what the lyrics mean, okay? Silent and secretive. Halchal halchal ho gayi teri. That one means you are all shaken, your lips are silent, as in not moving. You are all disturbed, you're sitting silently. We have seen that there is some sweet dreams in your eyes. Kehna hi kya, that part, कहना ही क्या ये नैन एक अनजान से जो मिले. That part means, well, what can I say? My eyes have met with a stranger's eyes. You got it perfectly correct about my origin, yes. चलने लगे मोहब्बत के जैसे ये सिलसिले. Mohabbat is love in Urdu. So it is as though a love story has started. Okay? That's the translation. I hope you're paying attention. अरमान ऐसे दिल में खिले जिनको कभी मैं ना जानूं. What does that mean? Wishes that I never knew I had are blooming in my heart. वो हमसे हम उनसे कभी ना मिले कैसे मिले दिल ना जानू. That means if he and I, she or I, they or I never met, well, how do I know that our hearts have met? अब क्या करे क्या नाम ले कैसे उन्हें मैं पुकारूं. That one means, well, what do I do now? What is their name? How do I call him or her, or them? This is an amazing and famous song. You need to listen and you need to take notes and you need to go listen to it yourself. It's by Chitra G. Um, okay, yeah. Jeremy, yes, how are you? Are you of Indian origin? I don't know. I don't know where I'm from anymore after translating the song for you guys. कहना ही क्या. I just woke up and you're singing about romantic songs. It's a very romantic song, guys. A very romantic song. If you don't know this, I don't know if you know love. If you don't know this song, I don't know if you've ever been in love. I don't know what to say. You need to know this song. It's a very old song, too. You've had plenty of time to know it. Kehna Hi Kya from Bombay. Lyrics with English meaning. K.S. Chitra. That's this singer. Kehna Kya. Don't speak much English. Just tell me straight, where are you from? Hi, Sahil. Gujarati. Mm. Okay, saying you. I'm sending the song to you guys. Kehna Hi Kya. The information about this song. Okay. It is by my favorite composer. You know the song now, if you didn't before. पहली नजर में कुछ हम कुछ तुम हो जाते हैं गुम यूं गुम. Example, all the psalms or music in Hebrew. Going straight into my playlist. Absolutely. Do it. Hi, Nitish. शर्म थोड़ी थोड़ी हमको आए तो नजरें झुक जाए सितम थोड़ा थोड़ा हम पे शोक हवा भी कर जाए ऐसी चली आंचल उड़ी दिल में एक तूफान उड़ी उठे हम तो लुट गए खड़े ही खड़े कहना ही क्या. Okay, I love this song. It's so sweet. It's so sweet. Hi, Michael. Hi, Vaughn. Yes, my sweetness. Hmm. Um, Vaughn. You watched that Indian movie Dhurandhar? Yes. Do Slayer. Mm, I didn't like it much, but I did like Akshay Khanna in it because I like Akshay Khanna. I don't really like Ranveer in it much. Like he was okay. Your hustle and bustle has disappeared. Your lips are silent. Your hustle and bustle. Why are you sitting silent? Hi, Elizar. Okay, guys, I have to go to bed. Enough. I I taught you physics and then I taught you Bollywood and I taught you a song and I told you the song and its lyrics and its meaning. I hope that you like, share, and subscribe. Who's calling me a Virgo? Good night, go to sleep. Thank you, Ali. Did you subscribe? Happy birthday. Hi, Punjab. Eliza. Hey, can you share my videos in live with your mom, dad, sister, brother, cousin, and ask them to subscribe?
I saw your kittens, Ben. Did you delete the post? Okay, no. All right, good. Mm. I'm replying to you. Hindi Urdu? That song? You should learn Hindi. It's not my native tongue because mine is Bengali. करे ही करे हम तो लुट गए करे ही करे. My face looks weird today. All right, guys. Thank you so much. Good night, Ali. Good night, Ben. Mwah, 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 mwah. Mwah. My girlfriend in college was Bengali. You should send her this live. And patch up with her. Thank you, everybody, so much. Love you, love you, love you. Miss you, miss you, miss you. And see you next time, okay? Hopefully, my face will be facing more.